Hello, good morning. Welcome to our presentation of Group 16. This is our Probability and Statistics class project in the topic Preference of Meals for People in Khittitaj University that uses campus cafeteria. I am Khittitaj and I will talk about my data collection and survey part. So, let's talk about what we are curious about. In the university, there are multitudes of cafeterias, and that are those of faculties and not of faculties. In a big university like Khittitaj, we have to understand the eating behaviors of most Khittitaj universities across many faculties. And following up from behaviors, we need to know what kind and what price range that is possible for Khittitaj cafeteria to be popular. And other factors too, such as height, weight, BMI, what faculty do they study in, and traveling distance from their desired building to their desired cafeteria. So our survey really targets those who use Khittitaj cafeteria, and our data is collected from multitudes of Khittitaj faculty.
Hi, I'm Chanunchida Dithakumarn. Today I'm talking about money spent on meal. The reason why we collect this data because we want to know and understand their money spent behavior on each meal. We collect data from 50 Khittitaj students, and we got minimum spending equal to 55 baht. Maximum spending is 100 baht. The median and mode is 50 baht. After remove the outlier, we got standard deviation equal to 12.736, and we got mean of this data equal to 53.56. From the graph, we see that the data is normal right skew distribution. Okay, next we collect data about the eaten at cafeteria per week. We collect this data because we want to know the frequencies of the cafeteria usage of KU students. We got minimum usage equal to 1 day, and the maximum is 7 days. The variance is 1.79. The mean of this data is 3.64, and median and mode is 4 days. Based on the graph, we got that the data is followed by normal distribution.
Hi, I'm Pathanutpong, and I'm here to talk about the relationship between cafeteria visits and their monthly food budget. But before we getting into the number side of things, I want to talk about the reason why we came up with this relation in the first place. The reason behind that is I don't think that there is much reason besides wanting to eat at a more luxurious places to eat outside of to having a higher food budget. So yeah, that's why we came up with this relationship. And let's look at the result from the heat map. The x-axis is the monthly budget, and the y-axis is the frequency of visits. Based on the graph, we can see that the trend is going down, which signifies the negative relationship. And we also conducted a correlation test. The result are the sample covariance is negative and person's correlation coefficient is negative, which further says that the result are negative relationship between both of them. But because the number of the person's correlation coefficient is close to 0, which means that the relationship is way too weak. So in the conclusion, we just say that the correlation between the monthly food budget and the preferred cafeteria frequency of visits is weak negative.
Okay, next is time taken to cafeteria. We claim that the average walking time to the cafeteria is less than 10 minutes. After removing full outlier, we sample data, and we got sample means and sample standard deviation equal to 6.17 and 4.1. And we set significant level equal to 0.05. First, this situation fit in large sample size of the hypothesis case. Step 1, we got mean equal to 6.17 and standard deviation equal to 4.1. Then we set the null hypothesis equal to 10. 3. Alternative hypothesis is mu less than 10. And 4. We compute test statistic equal to negative 6.336. Then 5. Due to we set the significant level equal to 0.05, we compute that the rejection regions will less than equal to 1.6449. Then the test statistics is less than the rejection region, so we reject the null hypothesis. And the conclusion is the average working time to a certain cafeteria is less than 10 minutes.
Hey, this is Nattanan, and I'm here to talk about the calculation part of the net of fit test. So the one we bring up today is the amount of day people decide to have meal at certain cafeteria. So first we gotta assume what the distribution is. Since this is the frequency, so it is the district. So we assume that it is the binomial distribution with n equals 7, which is the amount of day in 1 week, and p hat is 0.52. The null hypothesis is the number of day people choose to eat at the cafeteria is binomial distributed with n equals 7 and p equals 0.52. And the alternative one is the number of day people choose to eat at cafeteria is not binomial distribution with n equals 7 and p equals 0.52. After the calculation in the Google Sheet, we got k is 4, m is 1, which is the p hat, and after all the calculation, we got the test statistic is as 0.1319. So we gotta choose the cutoff. For the universal standard, we normally use 0.015, but in this case, we decide to choose 3 cutoff to make it more clearly. So we choose 0.01, 0.05, and 0.1. So after all the calculation, in all the cutoff, the test statistic is in non-rejection region, which means we not reject the null hypothesis. So we got the conclusion that the data of the day people choose to eat at the certain cafeteria is binomial distributed with n equals 7 and p equals 0.52.
And hello, this is me, Khittitaj again, to conclude our work. In terms of statistics, some of our data shows that people tend to eat from cafeteria closest to where they study, or let's say in this place, faculty building. And most of the students spend 30 to 50 baht per meal. There are some outliers, of course, in the hundredth, but that doesn't affect the mean and median much. For the probability, there are barely any correlation at all for both positive and negative side. As the data shown from previous slides, most of the data have extremely weak relationships. And we can conclude that after all this conducted experiments, each factors are mostly independent of each other. We may conduct a better research if we didn't overlook some important factors. This is our project in probability and statistics. Thank you for watching our presentation.